Problem 5. Now when you factor out the GCF of a polynomial, sometimes the expression that remains is a perfect square trinomial or the difference of two squares. Once you figure that out, then you can possibly factor the expression further using the rules from this lesson. Now, for example, if we're looking at 24g squared minus 6, and we want to know, is that a difference of two squares? Well, looking at it the way it is there, nope, it's not. Because 24g squared, because 24 is not a perfect square, and neither is 6. So those are not perfect squares. But if we factor out, let's say we factor out a 6, right? If we factor out a 6 on both of those, let me use a better color here. Let's use red. So if we factor out a 6 there and factor out a 6 there, we'll get 4g squared minus 1 with a 6 on the outside. Don't forget that. Then now you can see that 4 is a perfect square and 1 is a perfect square. And then we can factor using the rules from this lesson. So let's take a look at example A. And we want to find out what is the factored form of each expression. Well, looking at it now, looking at it as it is, we can see that 12 and 48 are not perfect squares. So in order for me to further check to see if we can factor this, we'll have to factor out a greatest common factor of 12 and 48. So the greatest common factor that we can take out of both of those is 12, right? So when I do that, the 12 goes on the outside, and we end up with t squared minus 4. Now, if you look at this, well, there, 1, because there's a 1 in front of that t, right? So 1 squared, or 1 is a perfect square, and 4 is a perfect square. So now we can use our difference of squares rule to factor this binomial, because that's a perfect square. That's a difference of two squares. So we can say that for A, we have the square root of t squared, which is equal to t. And then for B, we have the square root of 4, which is equal to 2. So we have our two second terms, or we have our two terms. Sorry about that, you guys. And we've got, let's see, we have to bring down the 12, and then we have t plus 2 and t minus 2. And there is our factored form. That's our final answer. And of course, you can check it using FOIL if you'd like. So why don't you try letter B? Why don't you try letter B? Pause the video. All right, so let's see here. 12, 12, and 3. Well, no, none of those are perfect squares. So we're going to say, well, what can I factor out of those to decide if we have a perfect square trinomial? Well, let's take out a 3. 3 here, and 3 there. So the 3 goes on the outside of the parentheses. Then we end up with 4x squared plus 4x plus 1. Okay, so now we can do some checking. So 4, is that a perfect square? Yes. 1, is that a perfect square? Yes. So that means that, let's see here, my A is going to be the square root of 4, which is equal to 2, and my B is going to be the square root of 1, oops, my b is going to be equal to the square root of 1, which of course is equal to 1. And then I have to check my middle term. Can I multiply, can I make, take twice to the a, so that's twice 2x, I mustn't forget that x, 2x, times 1, okay? So 2 times 2 is 4, times 1 is 4, times x is 4x. So this is a perfect square trinomial. So now we can use the a term and the b term, the a term and the b term, and write our binomials. So don't forget the term that you factored out. We need to bring that down. So now we have 2x plus 1, and because this is a trinomial and not a difference of squares, we're just going to have quantity squared. And there's our final answer. There you go.